In section 7 of chapter 5, we have the counting rules, the multiplication rule, the permutation, and the combination. Multiplication rule, the multiplication formula indicates that if there are m ways of doing one thing and n ways of doing another thing, there are m times n ways of doing both. Total number of arrangements is equal to m times n. For example, Dr. DeLong has 10 shirts and 8 ties. How many shirt and tie outfits does he have? 10 times 8 equals 80. Now that may be applied to more items. For example, Dr. DeLong may have 4 shoes or 5 pants. So in how many ways can he combine all of them? Well, 1600 if you multiply 10 times 8 times 4 times 5. And in general, the the multiplication rule can be expressed as n1 times n2 times n3, etc. times until you reach n sub k, where k is the number of different stages or the different items. That is the general multiplication formula, if you want to call it like that. Now, in the counting rules, we also have permutation. A permutation is any arrangement of R objects selected from n possible objects. The order of arrangement is important in permutations, so that AB is different than BA. Now, combination is a number of ways to choose R objects from a group of n objects. The same definition as the previous one, but without regard to order. So AB is the same as BA. So, for example, using the permutation case, if we have letters A, B, C, and I'm only selecting 3 letters because it's easier to illustrate, but I could have done A, B, C, D, A, B, C, D, E, but if you understand this one, you understand any other case. And you're going to select, let's say, 2 letters out of these 3 letters A, B, C. In the case of permutation, in how many ways can we combine this? Well, or in how many ways can we select 2 out of 3? Well, the formula is n factorial divided by n minus r factorial. So n factorial would be 3 factorial divided by 3 minus 2 n minus r factorial. So it will be 3 times 2 on the numerator, times 1 if you want to add the 1, divided by 3 minus 2, which is 1 factorial. Factorial of 1 is 1. So that will be 6 possible ways, and those 6 possible ways are AB, BA, remember these are 2 different outcomes, AC, CA, BC, CB. Alright, so those are the 6 possible outcomes. Now in the case of arrangements, in how many ways can I combine or arrange 2 items from the 3 letters? In how many ways can I select 2 letters from these 3, assuming that the order doesn't matter? So that's the case of combination. We have 3 in the numerator, and then in the denominator we have r factorial times, again, n minus r factorial. 3 minus 2. This is a 3 factorial. So it's the numerator, 3 times 2 times 1, but we don't need to include that. Then in the denominator, there's 2 times 1. And that would be 6 divided by 2, 3 possible outcomes. What are those possible outcomes? Well, AB, now remember BA we cannot include, so we have to go to AC, and CA is not possible either. And finally, we have BC, and CB is not included. Alright, so those are the 3 items, or the 3 different ways that two letters can be selected from 3, in this case ABC total, if the order doesn't matter. But if the order matters, then there are 6 ways, which is the top, the case of permutation. Now you can also have a general questions in how many ways can we arrange ABC. In other words, in this case, it is equivalent to calculate or to estimate in how many ways we can select 3 out of 3. Okay, so in the case of permutation, just apply the formula. It will be 3 divided by n minus r, which is 3 minus 3 factorial. On the numerator we have 3 times 2. On the denominator we have 1. The factorial of 0 is 1. So it will be 6 items. And in how many ways can we select this 3 out of 3 if the order doesn't matter, in case of combination? So it will be 3 factorial divided by 3 factorial. R will be 3. And then n minus r is 0 again, factorial. So it will be 3 times 2 on the numerator and 3 times 2 on the denominator. And remember, the factorial of 0 is 1. So it will be 1 here. And what is the outcome of the combination? Is just simply ABC. There's no other way you can arrange this, because the order doesn't matter. BAC, CAB, all of them are the same. But in the case of a permutation, you have ABC and ACB. You have BAC and BCA. And finally you have CAB and CBA. Okay, so excuse me. You have a total of 6 different outcomes. Okay, you can also apply this to different things, like suppose you go to Italy and you're going to visit city. Let's just call the cities City A, City B, City C, and City D. In how many ways can you visit the cities? Well, if you notice, you have 4 choices first. You have 4 choices first. And then once you choose one of them, let's say you select B, you have 3 left. So it'll be the equivalent to the multiplication rule. You have 4 ways of doing one thing, and then 3 ways of doing the second part, and then you have 2 cities left. Then you have 2 possible ways of doing that one, and then you're going to have 1 city left. So that'll be 12 times 2, 24. You can apply these concepts to more numbers. And notice that this answer is actually 4 factorial, which is just a permutation. If you use this problem and apply the formula for permutation, so it'll be 4 out of 4, in other words. Select 4 out of 4. It'll be 4, and then 4 minus 4 in the denominator, which is 1. So what is that equal to? 4 factorial divided by 1. Again, 24.